Thanks for coming, everyone. I'm Phil. I work with Soundcloud in Berlin. Well, I'll talk a bit more about what we are soon. But I'm here to talk a bit about what we've been doing in Soundcloud to keep our platform evolving. We are still a young company. We are, depending on how you count, but say 5 years old. And we've been growing a lot. And as a startup, there's a lot of trade-offs you have to make. So I'm going to focus more on the technical side of the trade-offs we've made and the techniques we've used, a bit on the organization side as well. So if you're more interested in organization and how people communicate to each other, we're going to see a bit of this, but also go a bit deeper on some more technical aspects of what we are doing. And the way I like to start talking about what we've been doing is talk a bit about myself, because that's just who I am. So I was a consultant for 4 years. I worked with ThoughtWorks. Some people in this room have also worked for ThoughtWorks. Consulting is really fun because you can travel a lot. I've lived in Australia, in the UK, in Brazil, and you get to know a lot of different companies, a lot of different cultures, a lot of different things. But also you get completely sick of living in hotel rooms. You get completely sick of being dragged into this big bank, waving your hands for 2 months and nothing happens, and you wave harder and still nothing happens. And you go back to the pub, get drunk, and say, you know what, maybe I need a change. I was living in the UK back then, and I fell in love with Berlin. If you haven't been to Berlin, definitely recommend. It's a brilliant, brilliant place. I was like, you know what, I need to find a job in Berlin. I need to go find something. And there's this very nice website called Berlin Startup Jobs, where it's just your typical job board for the Berlin companies, the Berlin startup scene, and not so much startup. And then I found this company called Soundcloud. I'm really into music. I'm not a musician. I have absolutely no talent, but I'm really into it, and I had never heard of Soundcloud before. And then I realized that actually a lot of players all over the internet who play audio, they come from Soundcloud. Soundcloud is the largest repository of audio on the web right now. We are not bigger than YouTube, but YouTube is a video repository, even though people use it for music a lot. But what we have is the biggest archive of music, podcasts, radio shows, everything. And what I really like about what we do is that we're really democratic, just like YouTube. You could be recording me right now using a SoundCloud iPhone app or Android app and post it to our platform and to your Facebook and to your Twitter, to your whatnot. But also it's the same platform that Britney Spears, Foo Fighters, The Guardian, and so many people use to push their sounds. So just like you find, it's really similar to what YouTube does in the sense that in YouTube you find quality professional content and you find some guy taping his cat. We have that. We have from bats having sex, and yes, we do have bats having sex, to The Guardian podcast or The Economist podcast, to Britney Spears, which I kind of like to consider the same level as bats having sex. But that's me. We have this widget which is everywhere. So if you go to a lot of websites right now, if you see the logo, if that was the first time you ever saw this logo, it's like when someone in your family gets pregnant and you walk around town and everyone suddenly is pregnant. So that's what happened to me. We are all over the web. We're just a bit hidden. And we grew a lot. We were started by 2 guys in a coffee shop in Berlin. They hired freelancers. They hired more people came. And we started, well, I think in 2011, we hit 10 million users. And these days, the official number is probably 40 million users, sorry. But we are at the stage where this kind of stuff happens, where if some famous artist, and it doesn't have to be Britney Spears or Bats, it could be some indie band somewhere. They put a music up now, a single, and they would have 1 million plays by the end of the day. So this is crazy. And if you think that because we offer statistics, we offer a lot of services around people consuming music and people providing music, we have to record a lot of information when it comes to this place. Sorry, my voice is a bit funny. So our numbers right now is like we have 10 hours of audio uploaded every minute. If you sit down for the rest of your life and just listen to SoundCloud content, you will not be able to listen to everything. And the official number is 180 million users a month. So that's including anonymous users as well. It's a lot of people. It's really big. Oops. So when you have a company growing this much in this short period of time, you have a lot of challenges. And some of them, as I was saying, are organizational challenges, some of how people communicate, how people work together. and some other problems are technical. When I was working as a consultant, I'd say half of my gigs were one way or the other. I would be writing code for 3 months, then spend 4 months just waving my hands in some meeting room, trying to get people to do workshops and to write cards. There's these two aspects of, I think, every single company, and every single company which is facing some massive growth, we always have these two. What I do not think personally is that you can, what I think is that people put a lot of emphasis in the organizational challenge and the communication problems, but a lot of these actually caused by technology. A lot of these are caused by bad architecture decisions or bad, or massive tech debt. And we just wrap some process around it, trying to make it a bit better. But we also have to tackle the core issue, which sometimes is just pure technology and bad choices. And that's why I'm going to lead from bad choices to Rails. So Ruby on Rails is a web framework written in Ruby. It's very popular. Twitter is a Rails shop. Groupon is a Rails shop. Living Social is a Rails shop. A lot of companies you use every day use Rails. We grew up using Rails. From day zero, all of our technology was built in Rails. And to be honest, I'm not the biggest Rails fan, but I do not think we would be where we are if it were not using Rails or something similar. What Rails gives you is a really fast feedback cycle. You can get things live in a really short period of time, but it's not like PHP, where you just mash things together and bang your head until it kind of works. Rails has some interesting patterns. It tries to drink from some good sources, from Smalltalk and even from the Java early days, and it does okay. The main problem is that the way Rails is sold is a bit like, okay, you come here to rubyonrails.org, watch this videocast, and you're going to see that Rails is really simple because that's Rails, right? It's just the typical MVC architecture for some value of typical, for some value of MVC. There's controllers which receive HTTP requests and they pass into these model things. And we have baked in object relational mapping, so you don't have to choose Hibernate, you don't have to do that. You can just use the one that comes with it. And you have a database, which is always MySQL. And that's it. Boom, it works. In 10 minutes, you can write a blog. That's right, you can do that. And the end result is going to have good enough quality, I'd say, much better than a lot of code that people put a lot of time on. It's not too bad, except that going back to the organizational side of things, Rails kind of leads you to build one big monolith. So if you have an application in Rails, you tend to have an application this big, and they start growing at the tunnel. We had this problem, and one thing that's interesting with this problem, Twitter also had this problem. Twitter is still solving from this problem, is still recovering, sorry. So if you go to twitter.com now, a lot of it is served from the new Twitter services, but if you go to a settings page, I think, all of it is still in their own Rails application someone wrote 5 years ago. But when it comes to organization, though, one interesting thing is that this leads to, well, this kind of platform makes it easy for us to have problem with Conway's law. Who knows what Conway's law is? Raise your hands. Okay, so Conway's law is, there's two things really we use the word law for, I think. One of them is like law of nature, gravity, thermodynamics, things that happen and we just try to understand how they happen. And other things is, I don't know, you should not steal from me, otherwise you go to jail. Or you cannot jaywalk, depending on where you live. These are the laws we make up. We make these laws because we think that this is better for society, this is better for us, this is better for this community. Conway's law is a law of the first kind. In a very interesting summary, it says that the structure of a system will reproduce the structure of communication of people building the system. The canonical example is if you have 3 groups of people working on one piece of software, you're going to end up with one piece of software with 3 modules. This happens a lot, and this, because it's a law of the first kind, you should not try to fight it so much. If you want to have a plane and want it to fly, you're not going to say, okay, there's no gravity anymore, now everything flies. You have to work with gravity, you have to make your way towards it. That's what happens a lot with Conway's law. And because the structure, as I was saying, the structure of the system reflects the structure of communication and the other way around, what you end up in a Rails code base is often with a really big team. And that's what we had at SoundCloud. When I first joined, I think we had, well, big team for a stand-up standard. I've been to teams with 60 developers. I've been to 200 developers. Now, at this stage, for us, a 10-people team is too big. It's a lot of overhead going on. And what's this kind of overhead? When you have 10 people moving at breakneck speed, like if you don't know who's doing what, it's really, really dangerous. I remember even in more traditional environments, when I was working for banks, I clearly remember pairing with someone for the whole day, going for lunch with some of the people on my team. At the end of the day, you try to check in your code just to realize that the guys across the hall built exactly the same thing, and they checked in first. So first you get really annoyed. But also, you're like, okay, so we're just wasting time. Why did I not talk to that person? Because this team is composed of, I don't know, 30, 50 people. I can't talk to everyone at all times. And I need to understand who is doing what, but I can't have all this overloading communication. But the wall tells you what the person is working on. It tells me what the person is working on. It doesn't tell me how the person is working on. And then you end up with this anti-pattern, well, at least in my experience, where the stand-up starts being the main point of communication across teams. There's those very long stand-ups where everyone tries to make sure they understand everything that's going on. People get bored and start messing with their phones. And if the team is too big, I've been to teams where we grew so much that we decided, you know what, that it's just too many people. Let's split. Let's have 2 groups having the stand-up at the same time. So we work in pairs, and then we split the pairs. Each part of the pair would go to one of the stand-ups. But then we had more people. We had, I think, 60 in the end. And we had 3 groups doing the same stand-up, and it would take 1 hour each. It was madness. It was crazy. You really don't want the stand-up to be the most critical point of communication in your team. It's just really the start of the end or whatever of your day. But the communication there should not be that should not be the only point of communication you have. And there's even some other teams which is something I find worse, and Thor works pretty good at doing that, which is a technical huddle. It's like just after stand-up, all the technical people get together and talk about the system. So if that's how you're passing the system vision, you're doing something wrong. Don't do that. This kind of communication should flow every day on a very natural basis. Especially you don't want developers to think that they have to interrupt work every 5 minutes to say, hi guys, what's going on? Communication should flow. So this is a problem with big teams. This is a problem we had in this team a lot. And a third problem, is that because we had a big team, because we had a big system, we had a massive backlog. At this stage, SoundCloud was growing enough to have different departments. We started with 1 product manager. I think we had 5 at this stage. And there's also marketing, there's also people from the content acquisition side, and they all want things. So I would be spending my whole day just going through this whole backlog and making sure that everything that made sense, clarifying what was not clear enough, making sure I was talking to people all the time, all the stakeholders are people outside from the development organization, the development team. And this is a lot of work. This is so much work that it often requires a full-time job, a person working full-time on just making sure this works. Because, yeah, sure, there's visibility on what's going on. But if I'm looking at a list with 100 items, and I want to see if item 98 can be deleted or not, I probably don't have that information now. I have to call someone. And this person is going to tell me, oh, can you hold on for a bit? I'm going to talk to so-and-so and then come back to you. It's a lot of work. And we are too small. We need to move fast. We don't have enough time, enough money, enough people to keep doing these kind of things. So these were the challenges we're having in the organizational side of business. But as I was saying, we also had challenges on the technical side, and there were a lot of challenges in that. One interesting challenge is that, so as I was saying, Rails kind of propagates this image of there is one system, there's one blob, and this blob is soundcloud.com. If you type that in your browser, there's a lot of stuff going on, it's just one thing. Well, it's not. We have a lot of different small systems within one code base. And each one of these systems have different needs, and a lot of them have different integration points. So the payment systems had to talk to PayPal, the other payment gateway, some some secured database, and whatnot. The other system had talked to Facebook. The other subsystem had talked to this, to that, to that. And then you have this one piece of code that talks to everything on Earth. And the moment you change one little parameter, it breaks everything else. This is like you're not acknowledging the fact that your application as a system is composed of multiple different parts. You're just mashing them together. And when you start mashing together, and especially in programming, if something is available in the same namespace, so if I can just import that module easy, I'll just do it. And in the end, you don't even know what's talking to what anymore. It's a bit too crazy. To make it worse, I was talking about the integration points, and there's this thing called the Golden Hammer anti-pattern, I think it's called, where you should not, when someone just uses one tool for everything, because that's the tool I know the most, that's the tool I really, really like. I don't know, let's write every single thing in Java or in PHP or in whatnot. This is really bad. You should not do that. You should really assess the problem at hand and what kind of tools you could be using and pick the best for that special occasion, including considering your team, what your team can do and not, and what kind of problems you'll be having. So the Golden Hammer kind of anti-pattern is bad, but in Rails it's double bad, because Ruby is quite a bad language and runtime at many different things. Integration, for example, is quite bad. It has pretty much no support for concurrent programming, not concurrent, parallel programming. It has no support for, well, no decent support for I/O. It's quite unreliable. If you want to do all these things, you have to do what we do now, which is to run 1 billion processes. We have, I can't tell you how many Ruby processes we have running at the same time, because each one of them is pretty much supporting just one request. And this requires a lot of work. This requires a lot of operations work, a lot of developer work. It's a bit crazy. And because the runtime of Ruby, which is called the MRI, unless you're using the Java version, it's not optimal. We have a lot of computation problems. When we were rolling out the new website last year, we were rolling out slowly to users. And one of our modules had, just to keep an in-memory array of some million of IDs. At some stage, we realized that the whole website, the whole request lifecycle, I think more than 30% was consumed just going through this array and doing basic mathematical operations on it. Like, okay, this is bad. We had to move this out of the process, cache all the things, and it was quite complicated to save up 30% of our time, which to us is a lot. In any high volume application, 30% is really, really big. And it was doing nothing. We're just seeking an array. So, okay, that's bad. So not only Golden Hammers are bad, but Rails is a particularly bad one. And Ruby is a very nice language, but the runtime's a bit funny. One thing that's less about Rails, but more about the organization of our code base is that when you have a service to 180 million users, stability is a big deal. If someone releases a new album now, and if you say, oh, we're going to be down for 10 minutes, it is a big deal. People start not relying on you as a platform anymore, and they'll move away. There's many different places they could go. So stability is really, really important to us. And because of the way things are meshed together, we are just as stable as the least stable bit. If this module just, I don't know, there was some wrong patch or something and it starts behaving funny, it's very likely that we'll either slow down the website a lot or take it down completely. Why? Because everything is on the same process, everything is on the same namespace, everything is a lot of shared code. What happens then? People start being really, really careful with changes. And that means they start having really long review cycles. I do a little change here. We use GitHub a lot inside Soundcloud. And GitHub, there's this feature called a pull request, which is really useful for open source projects. I find it funny to using this within a company where people should trust each other. But we have to, because you do a change, you work on it for, say, a day, you submit your change, and then you need like 3 people to review it. Not because they don't trust you, it's because no one in the whole company understands the whole. You need people from different parts of the system to take care. Oh yeah, no, actually this is going to break this thing you never heard of. Like, okay, fair enough. So this happens a lot. And after considering the problems we had with the organizational side of things, the problems we had with the technical side of things, we decided that the best solution was to split this. Split the teams and split the systems. We needed small teams, we needed small systems, we needed small backlogs. This was a hard decision because the company's been working on the old way for a very long time, and there's no one who could say this is not successful. We were successful. We got 2 rounds of investment. We were like getting new users, millions or hundreds of thousands of new users every day. So by what criteria you measure this not being successful? And the best thing we had was this pull request I was talking about. This queue used to take 3 weeks. So if you made a little change right now, you push it. It's going to take about 3 weeks for that to be deployed. Why? Because it's going to go in a queue. And then I would have to review a queue. But actually, I'm busy doing some other things. And then that guy's doing some other things. So we started doing Kanban for that. And then we had the I think it was a 4 items limit for the review queue, which everyone went on and just stormed through them, fine. But each one of those reviews could be there for the week. Why? Because the feedback cycle was crazy. I started doing something today. I spent the whole day doing that. When you got the review, it was already too late. You wouldn't come and say, oh, actually, all you've done is rubbish. So you would sit down with me and pair again and change things. And then we start having before someone would take a card from the wall, we would sit down and have a little meeting. And there was a lot of process for something that could be avoided altogether. So that's why we wanted small teams, we wanted small backlogs and small systems, which in my head is the most important thing. Really, there's a lot of talk these days, and I think I mentioned a couple of slides about microservices. That's what I'm looking for, like really 1,000 line of code tops services doing one thing and doing it very well, so we can maintain it easy, we can rewrite it if necessary without much fuss. So we had one system, we had, as I say, one big team, which for startup standards is 10 people. And actually finding these 10 people these days is really hard. So we decided to instead acknowledge the fact that we had multiple different systems inside and split it in small teams. What I've done is to create, I think the first split was 6 teams of 3 people each. I really like to work with the number 3 because 2 people is like being married to someone. Like either one of the parties is always wrong or no one agrees on anything. So the third person kind of gives you, the decision-making process a bit more determinism, maybe. But I really like having 3 people on the teams. I can't have it at all times because of staffing. We're hiring like crazy, but I really like working with these guys. And I also want to have a product manager attached to the team, at least one. This is a bit hard because we don't have many product managers at the moment. Product, not project, sorry. And the product managers we have, oftentimes they have to manage 2 or more things. And so it's a bit complicated. But we are trying to solve this problem by hiring more product managers which can focus on one thing. So right now I don't have anyone who spends 8 hours a day thinking of podcasts, for example. The same person that deals with podcasts deals with other stuff as well. And I don't think that's optimal. We really need to solve this problem. So, but we have these small teams. They have a project manager, sorry, I keep saying project, a product manager guy working with them, and they're able to make their own decisions. And it's amazing the kind of stuff you don't need to do when you have such small teams, because they know what they're doing. They sit together, they go for lunch together most days. Stand-ups become funny, because actually our stand-ups take 2 to 3 minutes these days, and it's mostly because I'm rotating across all the teams we have. Sorry, so it's the moment they have where they know that I have, up to 1 hour allocated talk to them. So using it more of a quick meeting every day than actually stand-up, because the communication that often happens in a stand-up in a bigger team, it just happens all day long. It doesn't need one specific spot to happen. That said, we still try to follow depending on the team, they follow different stand-up patterns, but they still try to do it just to see if there's something missing. But so far it's working very well. And also our planning meetings take half an hour. We are across of what's the priorities, what's going on, what the problems are. We are talking to each other every day, all day long. The main interesting thing about this is like, if you want to, when we decided to go for this, so I'm describing the end result, but when we decided to go for this, how are we going to do this? How are we going to make sure that we split this one big application into multiple different pieces? And it's still there's some cohesion, it's still there's some, it's not someone will go off and build one thing and the other guy was going to build another thing and they're not going to talk to each other. How are we going to structure this? We sat down, and one of the options, one of the things we were talking about is like, okay, maybe we should have an architect. We actually do have someone who's called an architect, just because I think some magazine once called us and asked for a list of people, and then someone from our PR said, oh, he's the architect, because it sounded better. But he's an engineer like all other guys. He works in a team. But we were like, okay, should we get someone to dictate what should be done, what shouldn't be done? And as a company, we don't really believe that, because we do a lot of very different things. And I don't think there's anyone in that company who could have a very good understanding of everything. We would rather have the individuals who are doing the work making these decisions. So like, okay, so if we don't think there's one godlike guy who can make the calls everywhere, so maybe we should have a small group of people making these decisions. Small group of people, they meet every week or something, and they work out what to do. And this is also funny because it starts becoming a lot of politics, and people, influence trafficking and all kind of stuff that happens when you get more than 5 people in a room. So it's like, yeah, that's a bit weird. So what about instead, we try to foster a culture where everyone is an architect. Everyone is responsible for understanding the system. Everyone is responsible for making the tough calls. We sit together when we need. Like, let's try this out. I've tried this with success in small teams. I haven't tried the whole organization. To get this going, we had to not only in terms of, okay, we had pretty much a plan. So now, well, we had some high-level vision. But how are we going to enable the teams to go for that? We had a big meeting. I had talked individually to everyone on my team, and then we had a big meeting. We worked out what the team splits were going to be, who's going to work with whom, and we also made sure people understood that in 6 months' time that could change. So we sat together, and one of the things we decided is that we were going to have a group working on how we're going to enable people. And the way we've done this wasn't by selecting random people we like or we think are capable. We just created a mailing list, created a calendar appointment every week. I think it was every Tuesday. This is actually a picture from one of them. We have a nice rooftop. And Berlin sometimes sunny during the summer. 2 days. And it's a joke. Berlin's very sunny actually during the summer. But we sat together once a week for some time. We still meet every now and then. But a mailing list was created, and everyone was invited to join. Technical people, non-technical people, whatever. What we're going to discuss is this, and that. And every single meeting, there would be an agenda, and it was a question. Every single meeting would start with a question, which should have been answered at some stage. There was a time box. I think it was 1 hour and a half at first, then 1 hour. But at the moment everyone was comfortable with the answer we had, we just stopped the meeting and go for beers. Not try to drag it too much, not try to create a lot of process around it. And we came up with a plan. It was a fairly simple plan, a very loose plan, but it was a plan. And the first step was to stabilize the legacy application. So we had the Rails application, and one of the things that really scared me when it comes to I've done Rails before joining SoundCloud, not at the scale we have, and not with the people we had. We have people who are referenced in, like there's people right now, there's a Rails conference in Krakow, and they're presenting that. So we have pretty good Rails people, and MySQL people as well. At the same time, we still have things like this. So this is the track model, which means this is probably the most important class for a company who deals with music and audio. And if you don't know Ruby so much, this is a definition of a class. And extend S3 is, well, there's a lot of interesting inheritance-like structures here. But pretty much the first line says, oh, this can be persisted to the database. Then it also has some S3 being Amazon S3, where we store our audio files. And then each one of these lines is a mixin being included. And a mixin is a piece of code you attach to a class at runtime. You don't write it here, but each one of these lines is pretty much including maybe 20 lines of code at runtime. So this file by itself, and that's not even touching where the actual code begins, would be like here. But this file by itself is, I think, 1,000 lines of code. If you want to flatten it and just include those lines of code added by these guys, I don't even know what the size of this thing would be. This is not different from what you will see in most big Rails applications. The small contrived examples, you're going to see the small blog, everything works very fine. The real world, that's what I've seen. And if I go visit different companies, and both in Berlin and in the US and in London, and everyone does something like that. And I was really like, why, how can we fix this? The way I'd done it in the past, where I was working with enterprise Java Beans, WebSphere and whatnot, was to buy books, just go to user groups, see what people are talking about. Unfortunately, Rails is a bit different because if you look at the culture, this is a blog post by the guy, DHH, who created Rails, who's a very opinionated individual. And pretty much this is a whole post talking about how dependency injection makes no sense in Ruby. And I mean, I understand that people have problems with dependency injection, but what I understand is this. he's saying that, for example, if you want to inject an instance of date in a class, you can do so and so differently in Ruby. Like, hang on, mate. You inject an instance of a date object in a class? I'm not too sure that means what you think it means. Seriously, you're throwing away a technique which could be useful for the community without even knowing what that actually does. This is the Ruby community. This is the Rails community specifically. And it's really frustrating, to be honest. So, but we have to do something. The way we've done was to create a stopgap solution with something like this. This is some code that suggests users. Actually, this code is in production. It's what suggests users in the who to follow box and in soundcloud.com/welcome. So what this guy is a service. It's a bit like what Eric Evans talks in domain-driven design, a crappier version of it. But this guy, what it has an initialize block, which is a construction in Ruby. It receives the dependencies. And then, if you know Java, C#, Python, this pretty much, or even like Ruby that's not Rails, this is just standard. This is what it does. It receives dependencies, works out with dependencies, really easy to test, was definitely test-driven. All nice. And then, the way we wire it to the controller, so the first block here is a controller in Rails, and the second block is a module we call suggestion support. We call something support, and everything this guy does is to instantiate one of these guys. So we make, there's the mixing going on in the first controller, so we make this guy accessible to that guy, from that guy, and then it just says, oh, suggestion service. So every time there's a suggestion service here, like, I think the laser pointer works, there's a suggestion service here, they would just call this method, which would instantiate a new one or use the one in cache. That's very simple, and that's horrible. This is what we used to do in Java 10 years ago. It's just bad. We moved away from it to many different things, but we know that sucks. That said, it's still much better than what we had before. It's still much better than this guy, with all the static references everywhere and doing all this. But there was a stopgap solution. There was an intermediate step. And some people across my teams decided to even try to extract some sort of framework and build something on top of it. So they started working with different things. And it turns out that they created a small dependency injection thing. It's not really a framework like we have in Java. They create something similar. But in the end, we don't need it, because what we do is to move away from this code base anyway. So we decided not to use it at all. Just keep the code simple and idiomatic, well, idiomatic to our standards, so we can move fast. So the second step was to create a common protocol. And why do we need a common protocol? Because when we got these guys isolating different systems, I told you that we went for microservices. And one interesting thing microservices let you do is to use different platforms. So right now, we have pretty much all these languages going on across my teams. And so we have Ruby, which is mostly on JRuby. We have a lot of Clojure, which is a Lisp for Java. We have Scala, Go, the language from Google, a bit of Haskell, and still more Ruby. One of them is supposed to be JRuby, I guess. What this does, the main thing we're trying to do here is to make sure we don't commit to a language before we actually use it. We're still a young company. It's like being a teenager. You want to try everything, and then you decide what you're going to do with your life. The microservices, these really, really tiny services you develop, allow you to experiment with Haskell for this specific piece. For example, we are building right now the new messaging system in Scala, and we're using some different libraries at the moment. If that doesn't work, it's a 2 weeks work. It's a 2 weeks job to rewrite it in something else. Oh, it's 2 weeks wasted. Yes, but we've learned a lot. And the process of learning also brings you a lot of stuff, including Clojure was a good example. Clojure was something we were trying out, and just let's see if that works. In the end, right now, I think most of our new services, most of new code within the application teams are being built using Clojure. It was just someone trying something out. We really enjoy the small code-based nature of these new services. There's some problems with it, which we'll discuss in a bit, but I like the fact that it allows us not to commit to something now. You've probably heard a lot today about less responsible moment. We are able to postpone the less responsible moment a bit longer. We really just want to try things before making a call. Just try it. We kind of have an agreement not to use anything besides those languages at the moment, even though we do have some C here and there. But if someone has a compiling case for some other language, we can probably swap one of the existing one with that or something, or maybe just add another one. That's not the moment to make lifetime commitment. This is time to try things out. Sorry, but when you have this kind of stuff, you need to make sure these guys talk to each other. It's not that hard. You have stuff like just RESTful APIs and HTTP and JSON. You have protocol buffers or Thrift, which are pretty good. And they're built by companies like Google, which have an architecture similar to this, or Facebook or Twitter. That's pretty much how they run their business anyway. So they're really stable, they're really mature, they're really good open source. And the most important thing when trying to make these guys talk to each other is that we should not publish rules. We don't actually publish anything. But in the wiki, you're not going to see rules of how to do this or how to do that. You see guidelines. You see that if we use so-and-so technology under this circumstance, there's probably a lot of support from our ops teams. There's a lot of code you could reuse. There's our libraries. There's whatnot. If you decide to use something else, then you're on your own. So, and also the whole thing about the 3-people team is that, that's probably important to mention. At SoundCloud, if you build something, you maintain it. There's no maintenance team. Every single support call, which is going to go through the community team, is going to hit you, and you have a pager. Everyone has a pager. There's some rotation schedule going on, and you're going to be, your phone is going to go off in the middle of the night for you to fix some problems. So you are very committed to making sure everything is stable enough, and you use like quite solid technology. So, but what we do is to build guidelines, because people are different. We have a lot of people, especially in the machine learning teams, they have very different backgrounds, and they sometimes want to use something they used at school during their PhD or whatnot, and we don't want to say don't use it. We want to say be productive. Maybe if enough people start using it, we will build support for it, bake it in our infrastructure. Which brings me to minimize non-technical overhead. So that's a bit of what I was talking about, the 3-people team. When you have a 3-people team, there's a lot of things you don't need to do. 3 engineers, 1 PM. Pretty much all teams we have are following this pattern at the moment. Really short meetings. Planning takes 30 minutes. Stand-up takes 5. This is working really well. I think if it's the biggest change we've made was this one. Or at least you can see it going quite well from the outside, even if you're not a technical person, if you don't write code. One problem I have with this is, especially my CTO gets a bit frustrated because sometimes he doesn't know who to email, depending on what, because there's many different teams now. And he emails me, problem. Oh, okay, I just forward the email to someone else. But besides these small things, which I'm not too sure quite how to address at the moment, this is working quite well. So we're talking about, that was about the non-technical overhead, but there's also the technical overhead. And one interesting thing when you go for microservices is that it should be really easy to push stuff to production. Really, really easy. It can't be hard. If it's hard, no one's going to do it. So what you need to do is that 5 minutes. What I need to do is to rush. What you need to do is to provide some technology or some platform for people to make it easy. Chef and Puppet are very good. We decided to build our own platform. It's something similar to Heroku, if you've done Heroku before. And it works, I will rush a bit, but it works a bit like this. The first line, sorry, maybe this wasn't the best one. So what you do, we use Git for everything as version control. You make a change, you commit, so Git commits something. Then you get your change, because Git commits in your machine. So you push your change to a server. And we have a server with a remote called Bazooka, which is the name of our platform. So it's pushed to Bazooka. And if you know Git, if you push to GitHub something, you see that it often stops here, and then it just returns to the prompt. In our case, it will execute some more stuff, because this server is not just a Git server, it's a build server. So when you send stuff to it, it will execute a specific target on your make file, which we use make just as an entry point for. This is a Scala project, and we use SBT for that. So it will actually build it. If this was good to go on, you see a Scala build going on here, and it tells you if it couldn't build well. It's really a lot like Heroku, if you have tried Heroku before. And then what you do, once this is true, your application is deployed. It's just not running. So you use this tool called Panzerfaust, which means bazooka in German. And you say, scale my process to one instance. So what that means is I want one, in this case, because it's a Scala project, it will fire up one JVM instance for that guy. In Ruby, you often say scale to 100. In Java, often 5, 10 is okay. And you don't know exactly where this is running at the moment. You know that it's running. And also, it supports different versions. So it scales down the old version and scales up the new version. And it tries to do it in a way where the service will always be up. So then you can just do a bazooka PS to see where your system is running. And you have like an IP address here, the server is running, the port is running, and whatnot. So it's really simple. It's really Heroku-like. And this works very well for us at the moment. It does require internal development. We have a team taking care of this platform. And there was some, I think we were naive thinking that we would just develop these and, treat as internal open source. It requires a full-time, it's a full-time for at least 2 people, but it's definitely a good thing to do. If someone, there's actually a lot of open source projects, and we do want to open source this, but there's other companies publishing open source similar versions of this. And if you're looking at things, microservice architecture, I definitely recommend taking a look at some of these systems because they make life much easier. But we still have people solving problems over and over and over. One example is from this Lisp code base we have, which is a Clojure application. And if you look at it, these were in theory written by 2 different people. But if you look at it, this is a configuration model. Even if you don't know Clojure syntax, you can see that these are very similar. There's like one difference here, and there's this line. Everything else is pretty much the same. You might be thinking that this was copy and paste, and you'll be right. We kind of, copy paste is always bad. If there's copy paste going on your team, there's something you're not doing. Except that one thing that we tried to do is to make sure that, again, we use before reuse. So we have very different types of microservices, and some of them have databases, some of them talk to to just web services and don't persist anything. Some of them talk to RabbitMQ. We just want people to, for the first, I think 6 months, we're doing this change, just to write the code and then wrap up in a library. So people start writing these, and obviously they're like following examples, which means they're using the same code. But after a while, what we've got was something like this. This is still work in progress. I was working on this code last night. But this is exported to a jar, and it just does the whole configuration setup for you, which is a lot like what these guys do, except it's more flexible. But this makes this kind of code, so one of this page, be reduced to this. So you just, here you just import, here you just import that library, which in Clojure can be just a jar file, and all that guy was literally replaced by this one line of code. So works fine, it's great. After doing all this, and after being 8 months or 6 months ish on this process, 8 months probably more correct. What's our current status is, it's a bit interesting. First, as I said, we have 6 teams. They have merged and split and whatnot. And I think this week I'm going to merge yet another team. Split, because there's one team doing too many things. And this setup are talking about 3 engineers, 1 product person. That's been working fine. We have a lot of microservices in Clojure, in Scala. Clojure is definitely the language we're using the most now, and it's a really, really good language for a lot of what we do, which is a lot of, most of our web services receive one HTTP request and then have to ask many different systems for things. Classic example is suggested user, for example. We have a classifier which was built to suggest users based on machine learning techniques. So this guy returns a list of, I'm representing user 123, which users should we suggest to this guy? So the classifier thing, it returns you a list of users which you could potentially suggest to the guy. But then you have to check one by one of these guys. Actually, is this account active? Because there is a delay, and maybe the account was just deleted. Or is this guy a private account? Or should we really be recommending this person because, I don't know, they don't have a profile picture and we only suggest people with profile pictures? And a lot of other kind of logic, which is not part of the classifying logic itself. So you make one call, you receive a list, and then you make, if the list has n elements, you make n calls. When you do that in Ruby, you pretty much have to serialize everything. In Java, whatever JVM language you use, you probably should not be serializing things. But with Clojure, that's really, really, really easy. Scala also is made easier, especially if you use the Twitter stack that we use. But enclosure is really great, and a lot of people like working with it. Also has pretty good tooling support. And we still have a lot of JRuby. So the pull request time I was talking about, 3 weeks, we kind of managed to reduce to 1 week. So now we still have the delay. We still have to control the pull request queue, control the size, make sure things are going through. But that was reduced from 3 weeks to 1 week, which is pretty good. But also, more than that, I don't think this metric captures is that there aren't these many pull requests anyway. It's just the ones that come in, they're complicated, so they do take 1 week because of complexity of the task itself. It's not just processed. I think we reduced by at least 60% the raw number of pull requests coming in every day, every week. But we're still very afraid of deleting code. We don't understand the code base much better at the moment, to be honest. We are migrating it. It's still a Rails 2 code base, and we are migrating to Rails 3. And part of the work is to understand everything. So there's a couple of guys going a bit insane at the moment and trying to, it's archaeology. It's just, oh my God, this person I never heard of wrote this piece of code. I can't even call them to ask what the hell was going on here. So we're still fairly afraid of deleting the code we have. What we are doing more and more is to use feature flags to put things to production with that one code path disabled, and see 1 week, 2 weeks, okay, no hit, no hit. And it's Ruby, so code coverage tools don't really help so much. Okay, 2 weeks, no one complained, let's delete that code. It's not great, but that's it. And we have black hole teams. So in the big team split, there was different systems, but that doesn't mean that we could find a home for everyone. We kind of grouped around areas. So I have a team taking care of the users and social graph. I have a team taking care of tracks and sets and whatnot. But I don't have a team take care, for example, email. So whenever someone comes with a request for email, first they have to come to me, because it's one of the situations that, like, I don't know who I should send this to. And like, oh, okay, I will find someone. And oftentimes that means find a team with capacity to work on it. I really, really dislike that, because ownership is a real big deal for me. I want people to own it, to be passionate about what they're doing. And if there's a news article on how Facebook sends emails, I want this person to just be attracted to this article and make sure we understand and we're doing the best, not as a side job. Everything should be important enough to deserve its own team. If it's not important enough, we shouldn't be doing that to begin with. And in the end, there's a lot of infrastructure to build. It's just moving from a was solid enough Rails application to a lot of different systems means that a lot of things which were baked into the Rails application have to be rewritten. We minimize it a lot by using JVM languages. We write a lot of code in pure Java so that you can use from all the languages. That's working okay, but there's still a lot of code to be written. A lot of our systems don't have the same kind of features when it comes to, say, database transactions as the main system. We're still working on it. We invested a lot in making our master-slave setup in MySQL work with Rails. We don't have anywhere close to the same infrastructure in Java at the moment, but we are going there. So 4 slides, real quick, just to wrap it up, because I'm way over time. So if I had to summarize all I tried to tell you guys, the first step would be as a plan to split the big monolithic code. First, stabilize the legacy app. Don't stop the word and say, let's rewrite everything, or just don't. If you're a startup like we are, if you do that for 3 months, it's already too late. The other guys are going to take market. People are going to complain that you look outdated and whatnot. The market we work on, there's no time to stop. You can make things slower, and especially you have to prioritize what you're going to do and decide what you're not going to do. But just don't stop the word. Create a common protocol. If you're going to split a big system in smaller systems, just make sure people know how systems should be talking to each other beforehand. Make it fluid as well, so have conversations frequently about what's working and what's not. And have examples are great. So point people to the code. Say, oh, you should do it this way, you should do it that way, as opposed to just have, I don't know, send a link or a book or something. Point to code in production you have. Minimize non-technical overhead. Small teams are great. They do not need a lot. When I was a consultant, I think if I were to, it would be a problem for me right now to step in my last gig, which was in a bank in the UK, and not just say, the reason you're spending, I don't know how many £1,000 a day with me here is because your team is too big. And obviously the person will say, so what, you want more £1,000? I have it, I don't care. But it's really, I'm learning a lot about what you don't have to do because you have small quite proficient, smart people working together. And the last one, just minimize the technical overhead. Make sure you made the boring decisions beforehand. No one, seriously, I've been doing this. I cannot have another discussion about which web framework to use. I just can't. Use whatever you want. I've been having discussion for 10 years. They all look the same. It's all the same stuff. Just make sure you make some decisions beforehand so that people don't have to have this argument over and over and over. But if they really want to use this one, this is fine. Seriously, they're not that different. And also, probably even more important is use then reuse. Don't build for reuse, because this has never worked. In this industry, this has never worked. Don't build for reuse. Build it okay for one single use. Use it again. Look at the commonalities. Then you extract whatever you have to extract. If you're going to use it a third time, don't overdo it. Don't think of it beforehand, because it's not worth it. And now over time, that was it. Do you have time for questions? No? So I'll be around. So if you have questions, maybe one question. Thank you.